The following video is going to be a refresher on how to factor a polynomial by using the Gcf technique. When we're doing this, remember the greatest common factor. You want the largest number that goes into all of the terms. And when you work with it, you do them separately. Find the Gcf of the coefficients first, then do each variable separately. So if I take a look, I have 4, 16, and negative 24. I mean, I can see they're all even. So I know 2 is a factor, but the question you have to ask yourself is 2 the largest factor? Is 2 the greatest factor? And it's not. I mean, 4, 16, and 24, I can see that 4 goes into all of those. And now we work with our variables. Now remember, when you're dealing with the variables and finding the GCF, you want to take the smallest exponent. So I have x cubed, x squared, and x to the 6th. And therefore, x squared is going to be my greatest common factor for my variable of x. I have y to the 5th, y cubed, and y squared. So then y squared is going to be the GCF. I have a z squared here, but no z's. And so the smallest is to not have a z. And so then I can see this is my GCF. And remember, you always end up with the same amount of terms in the parentheses that you started with. So you have a 4, you want 4, so you're not going to multiply the coefficient by anything. It's just going to be a 1, but we're not going to show it. You have 2 x's, you want 3, so you're missing 1 x. You have 2 y's, you want 5, so you're missing 3 y's. You have no z's and you want 2, so you need to put that z squared back in here. You have 4, you want 16, so you're going to be multiplying by 4. You have 2 x's, you want 2 x's, so those are already set. You have 2 y's, you want 3, so you're missing only 1 y. You have 4, you want negative 24, so that's going to be a negative 6. You have 2 x's, you want 6, so you're missing 4 x's. And you have 2 y's and you want 2 y's. And so that's it. And so I'm just going to fix my parentheses for it. And so the factored polynomial is 4x squared y squared times the quantity x, y cubed, z squared plus 4y minus 6x to the 4th. So let's try it with this example. 2, negative 4, negative 16. GCF of that is 2. A squared, a to the 7th, and a to the 1st. So then a to the 1st is the smallest, so we're just going to put a. B cubed, b to the 5th, b cubed. So then b cubed is the smallest exponent. C to the 1st, c squared, and c to the 6th. So c is my greatest common factor of the c variable. And then again, we're going to have 3 terms in our parentheses. You have a 2, you want a 2, so that's accounted for. You have 1a, you want 2, so we're missing 1a. You have 3 b's, you want 3 b's, so it's accounted for. You have 1c and you want 1c. So my first term in the parentheses is just a. You have a 2, you want a negative 4, so you're missing a negative 2. You have 1a, you want 7, so you're missing an a to the 6th. B cubed, b to the 5th, so you want 2 b's. You have 1c, you want 2, so you're missing 1. Now I take a look. 2 to get negative 16 is a negative 8. You have 1a, you want 1a. You have 3 b's, you want 3 b's, so those are already accounted for. You have 1c, but you want 6, so you're missing 5 c's. And so my final factored form is 2ab cubed c times the quantity a minus 2a to the 6th b squared c minus 8c to the 5th. And so this is just meant to be a refresher on factoring GCFs to practice more with variables and their exponents to make sure we get the factored form completely.